Hey guys, welcome to section number 2, and we are studying, you guessed it, bodies of water today. And so I've got my Scooby-Doo life vest getting ready to go right here, and I got my goggles, and it's time to talk about some water. So make sure you got something to write with so that you can take some good notes and that you understand what we are talking about in section 2 of chapter number 2. Now, the Earth is the only planet in the solar system that has as much water as what it does. No other planet is going to have as much water. About 71% of our Earth's surface is covered with water. And of course, we know that we need water in order to survive. So we have 5 oceans that you need to make sure that you know. And they're listed here on the screen for you. Make sure that you take those down. We've got the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Antarctic Ocean, sometimes labeled also as a Southern Ocean, and then we have the Arctic Ocean. I'm going to pull up here the labels that show where each of those oceans are located. You need to be able to identify where those are on the globe, and also you need to make sure that you know those. So I'll give you a moment to jot those down. If you need to hit pause what I'm saying, and get those written down, have a general idea of where those are. Now that we know where the oceans are located and the major bodies of water, it's important to understand how they all flow and work together. There's some motion that works within our oceans called ocean motion. That's fun to say. So the water circulates in 3 different ways. Make sure you get these down. It circulates through currents. Currents are where we have rivers flowing through the ocean and there's some movement going on below the surface. We also have waves. Waves can be a lot of fun if you're out surfing or you are swimming. But they can also be pretty big and dangerous. We'll talk about tsunamis later on. But they are swells that are produced by winds, typically, or sometimes these waves can be produced by underwater effects. Tides are the regular rise and fall of the ocean created by the gravitational pull of either the sun or the moon. And if you've been on the east or west coast, you've been near the ocean, you'll see the effect of these tides, where at one point of the day, the water can be really, really low. And you come back later on, and all of a sudden the water is really high. I've been out on the East Coast, and I've seen in Maine where these boats are tied up next to the dock, and I'll come back later in the afternoon, and they are all the way down on the floor of the sandy beach right there, and it's about an 8 or 10 foot difference. And it's something I'm not used to being a Midwestern guy, so it's pretty interesting to look at. The movement of the water can also affect the land, as it can either cool or warm the land around it, depending upon the temperature of the water. Now, it's also important to note here the hydrological cycle. And as you take a note on that, make sure that you understand what this is. It's the continuous circulation of water between the atmosphere, the oceans, and the earth. Okay, so your book puts it this way: the water exists in the atmosphere as a vapor. Eventually the vapor cools, condenses, and falls to the earth as precipitation, which means rain or snow. The water soaks in the ground, evaporates in the atmosphere, or flows into the rivers to be recycled. So, I'm not a huge science guy. I just thought it rained, and then it rained, and it rained again. So, it keeps recirculating. But it's just a big fancy way of saying that it rains, it evaporates, and it continues to circle. So, hydrological cycle is a term that's important for you to take note of and to remember. You can see on this graphic right here how it works and the different forms that water can take through rain, snow, condensation, all those type of things that are part of it. And that's part of what makes our cycle work correctly. Some other bodies of water that are important: lakes, rivers, and streams. We probably see a little more of this around our neck of the woods. But lakes are going to have 95% of all the fresh water on Earth, and we are thankful for that fresh water because that means that we can drink it. Cannot drink salt water. Just a little FYI, don't drink it. Seriously, don't. So, when we look at freshwater, the largest freshwater lake on the Earth is Lake Baikal. And I'll have to admit, I didn't know where this was. It's in Russia. For any of you that have ever traveled to Russia or have vacation plans to Russia, go check out Lake Baikal because it is the largest freshwater lake that the world has. So these freshwater lakes are formed by glaciers, and as those glaciers melt, the runoff forms into these low-lying areas that we call lakes. Now, a saltwater lake is where some of these lakes with heavy mineral deposits get stopped up, and then as the water evaporates, the salt's left behind. Most of us have probably heard of Salt Lake City, Utah. And Salt Lake, the Great Salt Lake in Utah is right in that area, and it's one of the more famous ones in the United States. The largest saltwater lake is the Caspian Sea, and you can find that in Western Asia. So as rivers and streams, as they connect together, they either run into bigger rivers and streams, or they start running out of them. These smaller branches that run into the rivers are called tributaries. They are the feeder system into those bigger rivers. And as a river starts to drain out a particular area, we call that a drainage basin. And that is where some of that water collects and drains down through the river. Now, as we look just outside our window and we understand that water collects from rain runoff, or we have a couple of days where it is really wet outside, we need to understand something about groundwater. We know that we typically don't see a whole lot of water on the surface of our roads. We're thankful for that, or maybe out in your backyard. But in order for us to understand why sometimes that does happen, we need to understand the water table concept. The fact that there is water that flows under our surface, and that water then can saturate our dirt and saturate the pores of the rocks. And as it rises higher and higher, as we have more and more rain, then that water table level can actually rise. And the higher the water table, the less amount of rain it takes for us to see some flooding going on. And as you see the graphic over here, that graphic helps us to understand how that works. And the drier it gets, when we have drought, or we have little amounts of rain, then the lower that water table goes, and the longer it's going to need to rain in order for us to see flooding. Now, changing gears just a little bit, we're going to go on land. The landforms are the naturally formed features on the surface of the earth. If you take a look in your book on pages 34 and 35, there's a whole bunch of landforms. And we'll get to know some of them we're not going to focus in on. For right now, you don't have to memorize that whole page, but it'd be good for you to take a look at that to get familiar with it. We'll talk about some of those in class and do a couple things with them. But when we look at the ocean landforms, one of the major terms you need to know there is a continental shelf. This is the Earth's surface from the edge of the continent to the deepest part of the ocean. And it usually extends from our major continents down toward the end of the deeper part of the ocean there. The Mid-Atlantic Range is the largest continuous mountain range under the surface of the ocean. And this is out in the middle of the Atlantic Ocean. You can Google that if you want to see some pictures of it, but that is an important area to know as well. Underneath the surface of our ocean, we have 4 major structures down there below the water. That's ridges, valleys, canyons, and plains. So even below all that water, there's still landforms that exist down deep in the depths of our ocean. Here you can see a diagram of the Mid-Atlantic Range and where that is located right between South America and Africa, and it extends all the way up through the Atlantic Ocean there. So the continental landforms, these are things that we're going to see on our continent. First of all, we need to understand a term called relief. Now, relief is the difference in elevation of a landform from its lowest point all the way up to its highest point. And so we call that relief. That's the difference there. There's 4 categories of relief, and those categories are mountains, hills, plains, and plateaus. So make sure you get those 4 down: mountains, hills, plains, and plateaus. And we will come back, we'll refer to those later on. The topography is simply a term that talks about all of the combination of those surfaces and how they're distributed throughout a region. So last chapter we talked about a topographical map. In this chapter we're talking about topography. That's where we put all those landforms together, helps us understand what features show up there on the earth. So I hope this has helped you. Go back and replay the video if you need more assistance in understanding what these mean. Read through the chapter, help you understand some of it. Hopefully this gives you some of the highlights, and we can help clarify it even more in class.